All right, so let's learn how to draw an oscilloscope trace of an action potential. Now, this word oscilloscope trace is not one that you've heard of yet. And this is an oscilloscope is just the device that's used to measure the difference in voltage across a membrane. And so imagine that you've got a neuron that's traveling like this. An oscilloscope is just a device that places a sensor right here and a sensor right here, and it measures the difference in voltage between the inside and the outside of the membrane. And that's where we get those numbers, the negative 70 millivolts and the positive 35 millivolts and all that kind of stuff. But we're just going to draw that action potential and make sure that we are able to annotate and label what is happening in each one of these parts. Okay, we're going to start off by making our graph. On the x-axis should be time in milliseconds, and our y-axis should be voltage, which is a measure of electrical activity in millivolts. We don't have to label what the x-axis values are, but we are going to label a few values on the y-axis. So let's start at negative 70 millivolts. This is what we call resting potential. At this point in the activity of the neuron, there's nothing happening. Now, right here, we're going to make our graph go up at about 45 degrees. Right here, this is where the stimulus has happened. The stimulus is something that is triggering the neuron to perhaps go ahead. But, like I said, you don't feel your clothes on you all the time. You don't know that you're wearing socks all the time because your neurons don't fire with every single little trigger. Like a level has to be crossed. And that level is at about negative 55 millivolts typically. And once we hit that level, which we call the threshold, that signal happens and we get a steep increase. Now, this is called the all or nothing response, which means that as soon as it hits, it's going to go through this whole motion whether you want it to or not. Okay, so I think we could label 1 as the stimulus and 2, and then at threshold, that's when number 2 is going to happen. And what happens in number 2 is that the sodium channels open up. Remember that there's a higher concentration of sodium ions outside the cell. So because of facilitated transport or facilitated diffusion, the sodium ions, which are charged, are going to come through the protein and into the inside of the neuron. This is called depolarization. And that's going to go all the way up to about positive 40 millivolts. At that point, number 3 happens, which is that the sodium channels close and the potassium channels open. The potassium channels open up. There's a whole bunch of potassium inside of the neuron, a higher concentration so that the potassium will flow out of the neuron. And because those positive charges are leaving the neuron, it's going to go down. And we call this not depolarization, but since we're kind of going back to normal, we call it repolarization. Now, a lot of potassium ions leave. The neuron returns back to being more negative inside than outside. So we go into this massive negative kind of debt here. Okay, now down here, the potassium channels are going to close. Now we need to kind of reset everything back to where we are. This massive dip is called a hyperpolarization. And this hyperpolarization happens so that the neuron has, this part of the neuron has a quick second to kind of put everything back to it where it is so that it can all happen again. And this prevents the impulse from traveling backwards. So once again, here at number 4, the potassium channels has closed. The potassium channels have closed. And then number 5 is going to happen, which is the sodium-potassium pumps kick back in. Now, this is active transport. This is going to take energy because we're going to pump a whole bunch of sodium ions outside. We're trying to pump sodium ions into a high concentration area because we want there to be a high concentration so that they will come in naturally. And then we're going to pump a bunch of potassium ions into the neuron. And so the exact ratio is that for every 3 sodiums that get pumped out, 2 potassiums are pumped in. And this happens until we get to negative 70 millivolts. We have a high concentration of sodium ions outside of the cell and a high concentration of potassium ions inside of the cell. Now, when you do your drawing quiz, like those numbers, 1, 2, 3, 4, 5, need to be described. They need to be annotated. You need to be telling me what's happening in each of these particular points. Now, remember that this is only happening at one part of the neuron. When this happens at one part of the neuron, it triggers the next part of the neuron to do that, and the next part, and the next part, and the next part. All right, that's it.